Assalamualaikum warahmatullahi wabarakatuh. My name is Alma, Zalikha binti Ahmad, Zamzuri. I'm from group CEEH2433B, and today I will be presenting the question +1. Alright, so the first question mentions to find even function and sketch the function for several period, and also to determine the Fourier series of fx. So this is the function that I've written, 1 minus x and also 1 plus x with the intervals, and also the period here is 2 pi. I've sketched the graph and this is how it looks like. Alright, so how to sketch the graph? Firstly, for function fx 1 minus x, from interval negative x is from interval negative pi to 0. So we just substitute the value negative pi and also 0 in this function. So 1 minus x, when x is equal to negative pi, we just insert the value negative pi into this function, and we get when x is equal to negative pi, y is equal to 1 plus pi. Next, we just insert the value 0 and substitute into this equation, and we get when x is equal to 0, y is equal to 1. And the same goes on for the next function. Moving on, for even function, we have to find the value of a0, an, and then we are able to insert these values into the function Fourier series. For even function, the bn value is 0, so we don't have to find the value of bn, as we already know that this function is an even function where the value bn will be 0. Moving on, to find a0, we have to use the formula a0 equal to 1 over L from integral negative L to L fx dx. So for this particular function, the value of L is equal to pi. How? As we already know that period is equal to 2 pi, so 2L equal to 2 pi, then L is equal to pi. Alright, moving on. So we just insert the value, since we have two functions, which is 1 minus x and also 1 plus x, we just okay, for the value for the function 1 minus x, the interval is from negative pi to 0. So we just insert negative pi and 0 into this function, and then we integrate it as usual. Same goes to another function, which is 1 plus x with interval x from 0 to pi. Alright, so just integrate it like usual, and then we will get value of a0 is 1 over pi in bracket 2 pi plus pi square. Moving on, we have to find the value of an, which we will use the formula of 1 over pi. 1 over pi is 1 over L, and then interval negative L to L, negative pi to pi, and fx cos nx dx. So the same thing, since we have two functions, which is 1 minus x and also 1 plus x with different intervals, so we have to include those intervals into their respective functions. Alright, so as we could see here, we have we want to integrate 1 minus x cos nx dx, so we have to use tabular method to solve this integration, and also the same goes for the function 1 plus x and 1 plus x times cos nx dx. Right, so here I share a little bit the working for tabular method, and then moving on, just solve the integration and then simplify them, and then finally we have the Fourier series function. We just have to include the value of an and also a0 that we have already calculated before. So this is the function Fourier series for even function. Right. For the next question, it asks to create any odd function and then sketch the function for several period, and then find the Fourier series. So this is the function that I have written here. We have two functions, x plus pi and also x minus pi, with respective intervals, and also the period here is also 2 pi. So so this is I have sketched those functions into this graph, and how to sketch it is also the same like how I have said as how I have explained before. Moving on, for odd function, it is important for us to know that for odd function, the value of a0 and also the value of an is equal to 0, so we don't have to find the value of a0 and an. So for odd function, we only have to find the value of bn, because it is the only value that exists for odd function. Right. So we just find the value of bn using this formula. For this formula, and then as you can see here, we have to integrate x minus pi times sin nx dx. So it is the same thing as I have explained before. We have to integrate this by using tabular method. So by tabular method, I get this answer. So for odd function, just have to insert the value of bn, because it is the only value that exists. So we don't have to find the value of an and also a0. We have to find the neither not or even function. Right. So this is the value that I have written And we have the function fx equal to 1 with interval x is from 0 to 1, and also the function fx equal to -2 with interval from x is equal -1 to 0. Right, so I've sketched the graph here, and the period is equal to 2. Right, so because this is neither not or even function, we have to find the a naught value, we have to find the an value, bn, and also so we have 3 values to find. All right, use the formula. By using the formula, we just insert what is the value of L, and then insert the value of fx given, which is -2 and 1, but insert those values with their respective value of interval. Right, and then we get the value of a naught, and then for the value of an also, we just use the formula, and then we can find the value of an. And then for bn, also we just insert the value in the formula. All right, so and then simplify the working, and then we get this answer. All right, so for the Fourier series, for the neither, not, or even function, we have to have the value of an, bn, and also a naught. All right, so that's all from me. Thank you.
Okay, for task 2, we'll be using the function of fx equals to x squared, where the interval is between 0 to +2. For the first question, we have to find the expansion of Fourier series in a cosine series. First, we need to sketch the graph of x squared from 0 to +2. Let's look at the solution. The green line is the graph of x squared from 0 to +2. The graph of cosine series must be symmetrical about vertical axis, so the other line is symmetry with the line just now. The period in this question is 4, hence the value of L is 2. We need to know that cosine series has a value of Bn equal to 0, so we need to find only a naught and an. The fx for cosine series is a naught over 2 plus an cos n pi x over L. Then we have to find the value of a naught. The formula of a naught is 2 over L times with the integration of fx dx with the upper boundaries is L and the lower boundaries is 0. So we need to substitute the value of L and the value of fx. L is equal to 2 and fx is x squared. So the value of a naught that we have calculated is 8 over 3. Then we have to find the value of an. The formula of an is 2 over L times with the integration of fx cos n pi x over L, with upper boundaries is L and the lower boundaries is 0. Then we have to substitute the value of L and fx like we did to find a naught. After we have substituted, we need to solve this integration by using tabular method. After we use tabular method, we just need to solve the question like normal integration. The value of an that we have calculated is 16 over n pi squared cos n pi. So after we have got all the a naught and an, we have to substitute the values into the formula of fx just now. After we have substituted, we get the fx is equal to 4 over 3 plus 16 over n pi squared cos n pi x over 2. Okay, for the next question, we have to find the expansion of Fourier series in a sine series. Then we have to sketch the graph of x squared from 0 to +2. Okay, the graph of sine series needs to be reflected in the horizontal axis and the vertical axis. It needs to rotate about 180 degrees. Okay, the green line that we have in the solution is 0 until 2, and then we have to reflect it to horizontal axis and the vertical axis. So this line is the line that we have reflected. Okay, the period in this question is same as in the cosine series. The period is 4, hence the L is equals to 2. The fx for this sine series is Bn sine n pi x over L. So a naught and an in this question, in this sine series, is equal to 0. So we only need to find Bn. Okay, the formula of Bn is 2 over L times with the integration of fx sine n pi x over L, with the upper boundaries of L and the lower boundaries is 0. So we have to substitute with the value of L is 2 and the value of fx is x squared. After we have substituted the value of L and fx, we get this integration. So we have to solve this integration by using tabular method also. After we have performed the tabular method, we need to integrate like in normal way. So the value of Bn that we have get is -8 over n pi cos n pi plus 16 over n pi cube times with cos n pi minus 1. So we have to substitute this value of Bn into this formula. Hence we get the Fourier series for sine series is -8 over n pi cos n pi plus 16 n pi cube cos n pi -1 times with sine n pi x over 2. Next question, we have to find the expansion of Fourier series in a Fourier series which neither even nor odd function. The period in this question is equal to 2. It is different from the previous questions that we have solved. So the value of L is equals to 1. Okay, the graph of x squared that we have sketched is from 0 to 2. The graph for Fourier series needs to be sketched repeatedly. Okay, the fx for Fourier series in this question is a0 over 2 plus an cos n by x over l plus bn sin n by x over l. For Fourier series, we have to find a0, an, and also bn. The formula for a0 is same like the previous question, the previous solution that we have solved. Hence, we only need to substitute the value of L, which is 1, and the fx is equal to x squared. Then we have to solve the integration, and we get a0 equals to 8 over 3. Then the formula of an also same like the previous question. We have to substitute the value of period, and this is the value of L. The formula is 2 over L times the integration of x squared cos n by x over 1. After we have substituted the value, we have to solve the integration by using tabular method. After we have performed the method, we need to integrate like usual. So we get the formula, the answer for a0 is equals to 4 over n pi square. Next, we have to find bn. The formula for bn is 1 over L times with the integration of x squared sine n by x over L. So the upper boundaries is 2 and the lower boundaries is 0. That seems like bn. We have to solve this integration by using tabular method. After we have performed tabular method, then we integrate as usual, and we get the answer for bn is equal to negative 4 over n pi, 4 over 3 plus 4 over pi times with 1 over n square pi cos n pi x minus 1 over n sine n pi x. Okay, for task 3, we have to find the Fourier series expansion up to the third harmonic. So we have put the values of fx. So all of these are our values of fx. After that, we have to construct a table that consists of x, fx, fx cos x, fx sin x, fx cos 2x, fx sin 2x, fx cos 3x, and lastly, fx sin 3x. We have to find until 3x because the question asks us to find the series expansion up to the third harmonic. After that, we have to fill in the table with the values that have been given in the question. Then we have to calculate the value. We have to find the value for each row and each column. Then we have to find the sum of each column. Okay, for example, the sum of fx is 27.7 and the sum of fx cos x is 3.109 and so on. You have to calculate the sum of each column. After that, we have to find the values of E0, C0, A1, B1, C1, alpha 1, A2, B2, C2, alpha 2, A3, B3, C3, and alpha 3. Okay, first we have to find the value of A0. And the formula for A0 is 1 over 6 times the sum of fx. Okay, the sum of fx that we have calculated is 27.7. So we have to substitute the value into the formula and we get A0 is equal to 4.617. After that, we have to find the value of C0. And the formula for C0 is 1 over 2 times A0. Substitute the value of A0 into the formula and we get C0 equals to 2.309. After that, we have to find the value of A1, A2, and A3. The formula for A1, A2, and A3 is almost the same, but the only thing that different is A1 has to multiply x with 1. For A2, the x has to be multiplied by 2, and for A3, the x has to be multiplied by 3. Okay, for A1, we get the answer is 0.518, and A2 is negative 0.908, and A3 is 0.033. After that, we have to find the value of B1, B2, and B3. The formula for B1, B2, and B3 is almost the same, but the only thing that is different is the B1 have to multiply the x with 1, and B2, the x has to be multiplied by 2, and for B3, the x has to be multiplied by 3. Okay, the value for B1 is negative 0.327, and the value of B2 is 1.660, and B3, and the value of B3 is 0.283. After that, we have to find the value of C1, C2, and C3. The formula for C1, C2, and C3 is the same. Okay, let's look at C1. The formula of C1 is square root of A square plus B square. Okay, for C1, we get 0.613, and C2 is 1.892, and lastly, C3 is 0.285. After that, we have to find the value of alpha 1, alpha 2, and alpha 3. Alpha 1, alpha 2, and alpha 3 share the same formula, which is tan inverse A over B. After that, we have to substitute the value of A and B into the formula. But we must remember that we have to consider the quadrant when we trying to solve this question. Okay, for alpha 1, tan inverse 0.518 over negative 0.327 is in the quadrant 2. So after we consider the quadrant, we get 122.263. And for alpha 2, we consider the tangent inverse negative 0.908 over 1.660 is in quadrant 4. So the value is the value of alpha 2 is 331.322 degree. And for alpha 3, tangent inverse of 0.033 over 0.283 is in the quadrant 1. So the value is 6.651 degree. After we have find all of these values, which is E0, C0, A1, B1, C1, alpha 1, A2, B2, C2, alpha 2, A3, B3, C3, and alpha 3, we have to substitute all the values into the general formula, the general form of Fourier series in harmonic analysis. Okay, here we get fx equals to 2.309 plus 0.613 sine x plus 122.263 degree plus 1.892 sine 2x plus 331.322 degree plus 0.285 sine 3x plus 6.651 degree. Okay, the value of 0.613 we get from the value of C1. This is C1, and 2.309 is C0. Okay, this is the value of x, and this is alpha 1, and this is T2, alpha 2, C3, alpha 3. Okay, that's all from us. Thank you.